Betelgeuse, a red supergiant in the constellation Orion.
If we take the lines away, the most interesting star, I think, the star that could be shocking in our sky is this one, Betelgeuse or Betelgeuse. It's a red giant star. If you put it where the sun is, it would extend out to the orbit of Jupiter. It's enormous. It's very unstable. It's about to explode.
Astronomers have been watching the sky closely, and one star, Betelgeuse, has been causing quite a stir. When scientists pointed the James Webb Space Telescope at Betelgeuse, they noticed something unusual. This discovery has set off alarm bells in the scientific community, especially among experts like Brian Cox, a famous physicist. Cox warns that Betelgeuse might explode into a supernova at any time, which could have significant implications for us on Earth. So, what could happen if Betelgeuse explodes and becomes the main focus in the night sky? Are we standing at the threshold of a cosmic event that will negatively impact our everyday lives here on Earth? Come along as we delve into this concerning news about the Betelgeuse supernova and its implications for our night sky and the world as a whole. A stellar showstopper in the night sky. Betelgeuse stands out as an extraordinary celestial phenomenon on the verge of becoming a supernova. What makes it distinctive? Well, it's an immense star, surpassing our Sun by 700 times in size and being approximately 15 times more massive. This supergiant, as it's well known, behaves as a cosmic mystery. Researchers are consistently fascinated by its irregular dimming, which happens about every 430 days. Every 6 years, like clockwork, large dark spots show up on its surface, similar to the sunspots we observe on our Sun, but on a much larger scale. This has caused concern among scientists, particularly prominent experts such as physicist Brian Cox. Cox cautions that Betelgeuse could undergo a supernova eruption soon, potentially impacting Earth in significant ways. This giant underwent a particularly dim phase in February 2021, shining a bit less brightly than usual. Despite its immense size, Betelgeuse emits less energy per unit of surface area compared to our Sun, because it runs cooler at around 3,500 Kelvin, while our Sun sits at a toasty 5,500 Kelvin. That's why it sometimes seems dimmer than expected. Betelgeuse has been stealing the spotlight in our night skies for ages. Even Greek astronomer Ptolemy took note of its reddish hue. Back then, they only had color and position in the sky to describe stars. But thanks to modern astronomy armed with advanced techs like the James Webb Space Telescope and the Hubble Space Telescope, we've unraveled a lot more about this celestial giant. The Hubble Space Telescope's detailed images revealed patterns of gases and dust clouds on Betelgeuse's surface, while the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory caught a light wave coming from the Orion constellation, where Betelgeuse sits on the left shoulder of Orion. But there's more. ALMA, an observatory in Chile, provided ultra-high-resolution images of Betelgeuse's surface, giving us a closer look at its behavior. Scientists discovered an expansive gas plume extending from the star's surface, likely a result of Betelgeuse's pulsations caused by the cyclical movement of hot and cool gases within the star. These pulsations create star spots, areas with intense magnetic activities and cooler temperatures compared to the rest of the star's surface. These spots, believed to be much larger than Earth, directly influence Betelgeuse's brightness. The more star spots, the dimmer the star appears, making it a fascinating puzzle for astronomers to decipher. Now this is where it starts to get intriguing. The countdown to Betelgeuse's supernova. The recent gravitational wave readings from Betelgeuse have stirred quite a buzz among astronomers. You see, the dimming we've been observing is a bit of a telltale sign in the cosmic drama of a star approaching the grand finale of its existence. But here's the twist. Stars, like Betelgeuse, with their magnitude and brilliance, don't gracefully fade away. No, they prefer to go out with a supernova explosion, befitting their cosmic stature. Now, Scientists are contemplating the possibility of Betelgeuse putting on this spectacular celestial show. If it happens, it would be like hitting the cosmic jackpot, offering us invaluable insights into the mysteries of the universe. Imagine witnessing a red supergiant bidding farewell in a fiery blaze, observable even in the daylight. Intriguing, right? Recent data from the James Webb Space Telescope and the Hubble Space Telescope hint at some fireworks a few years ago when Betelgeuse underwent a significant eruption, losing a chunk of its visible surface. This triggered a massive surface mass ejection, basically a cosmic sneeze that raised eyebrows among scientists. It's not your typical star behavior, especially for one of Betelgeuse's stature. Despite ongoing scrutiny, the star seems to be on the road to recovery from this substantial ejection. But the recent phenomena surrounding Betelgeuse remain a cosmic head-scratcher for scientists. It's like the universe is teasing us with its celestial puzzles, and Betelgeuse is at the center of it all. Observations from the James Webb Space Telescope provide a fascinating peek into how red stars shed mass as they approach the end of their cosmic journey. Betelgeuse, in particular, seems to be shedding mass at an unprecedented rate. The recent significant loss of mass raises some serious questions about the fate of this colossal red star. Scientists are on high alert, working diligently to unlock the mysteries of these occurrences. The massive ejection of mass from Betelgeuse is thought to have originated from a convective plume spanning over 1 million miles across its surface. This plume, like a cosmic fountain, generated powerful pulses and shocks, leading to the expulsion of a chunk of the star's outer layers. The result? An expansive surface beneath a dust cloud, a cosmic aftermath visible from our little blue planet. Betelgeuse, now grappling with the fallout of this upheaval, experienced a significant dimming in 2019. The lost mass, weighing several times more than our moon, dispersed into space, forming a dust cloud that played hide-and-seek with the star's brilliance for several months. Even amateur astronomers, armed with just their passion for the cosmos, noticed this cosmic spectacle. The universe sure knows how to put on a show. Clues, controversies, and the supernova puzzle. For more than 2 centuries, scientists and astronomers have been closely studying Betelgeuse, noting its rhythms and movements. They've meticulously documented noticeable disruptions that underscore the profound impact of this stellar blowout. Recent analyses from the TRES and Hubble spectra indicate that while the outer layer may return to normal soon, the star's surface remains in a delicate state, awaiting the completion of the photosphere rebuilding process. In contrast to our Sun's coronal mass ejections, Betelgeuse's recent surface mass ejections highlight a stark difference in magnitude. Betelgeuse's expansive growth over millennia is evident, with its outer orbit potentially extending beyond Jupiter's. The red hue of Betelgeuse signifies that it has reached a stage where stellar bodies deplete their hydrogen reserves, leading to core collapse and the outer layers puffing out. Comparatively, our Sun is still relatively young, with an estimated 5 billion years before reaching a mature stage where its radius may expand to proportions reaching Mars's orbit. After the significant dimming of Betelgeuse in late 2019, scientists scrutinized its altered behavioral pattern. Despite regaining brilliance within months, the initial cause of dimming puzzled scientists. Various hypotheses were proposed, including star contraction before an impending explosion. However, data from NASA's James Webb Telescope dispelled this theory, attributing the dimming to dust clouds raised from ejections. Scientists now believe a supernova event is not expected for another 1.5 million years, placing Betelgeuse in its late evolutionary stage. According to Salvatore Vitali, a physics professor at MIT, the detected wave from Betelgeuse may not necessarily originate from the star itself. Vitali points out that before a supernova, neutrinos are typically released, which hasn't happened in Betelgeuse's case. The fact that Betelgeuse still illuminates, albeit dimmer than usual, makes it an unlikely source for gravitational wave emission. Uncertainty surrounds whether the intercepted wave is indeed a gravitational wave, as it lacks characteristics of known mergers. The cause of the detected wave remains elusive, and the debate continues among researchers. The ongoing debate among researchers about Betelgeuse's potential supernova includes speculations about its imminent end or the possibility of tens of thousands of years left. The most recent supernova observed in our Milky Way galaxy was in 1604, with potential subsequent nearby supernovas hidden by atmospheric gas and dust. Instances like the Crab Nebula from a supernova in 1054 serve as remnants of explosive events. More recent observable occurrences include the 1987 supernova in the Large Magellanic Cloud and the Kepler supernova in galaxies beyond our Milky Way. Probing cosmic explosions through modern telescopes. Witnessing a star explosion in our galaxy is rare, with astronomers estimating an average of 1 to 3 supernovae every century. Modern telescopes, compared to those of Kepler's time, are better equipped to capture visible light and provide insights into how supernovae would appear if observed nearby. Infrared telescopes like the James Webb Space Telescope extend beyond visible light, penetrating gas and dust to reveal celestial objects not visible with conventional telescopes. The dynamic nature of the universe continues to unfold before our eyes. Apart from observing light, scientists employ specialized detectors to catch neutrinos and subatomic particles emitted by supernovae. These detectors, alongside instruments for gravitational waves, offer another dimension to studying these cosmic events. Supernovae fall into two main types. Type 1 involves a runaway nuclear reaction in a white dwarf star, while Type 2, known as core collapse supernovae, results from a star collapsing under gravity after running out of nuclear fuel. Type 2 supernovae are particularly fascinating, as they emit not only light, but also a significant amount of neutrinos. Neutrino emissions might even precede the visible explosion, allowing detectors to pick up signals before the actual event occurs. Betelgeuse, experiencing recent brightness fluctuations, sparked speculation about a potential supernova explosion. However, recent research suggests that the dimming might be attributed to dust clouds or sunspot activity on the star's surface. Nonetheless, anticipation remains high among astronomers for the eventual explosion of this massive star. To enhance detection capabilities and provide an early warning system, astronomers have established the Supernova Early Warning System, SNOOS, a network of neutrino detectors across various countries, including Antarctica. SNOOS aims to automatically alert astronomers if galactic supernova neutrinos reach Earth, offering valuable data for studying the event. The upcoming SNOOS 2.0 seeks to improve triangulation capabilities. Advancements in neutrino science since the 1987 A supernova suggests the potential capture of thousands or even hundreds of thousands of neutrinos by a global detector network during a galactic supernova. If a collapsing star forms a black hole, the sudden stop of the neutrino stream could signal this phenomenon. Astronomers could identify potential black hole locations by observing blank spaces in lists of known stars. While massive stars undergo captivating supernova explosions, their proximity to Earth raises safety concerns due to potential dangers if an explosion occurs within a specific minimum safe distance. Evidence of a starburst around 3 million years ago near Earth has been discovered through the presence of radioactive iron atoms in lunar cores and deep ocean samples. These unique atoms are traces of supernova explosion remnants, enabling scientists to study the nuclear processes driving exploding stars and uncover events predating recorded human history. A nearby supernova, like one that occurred close to Earth, likely released significant radiation throughout Earth's history. Despite these cosmic challenges, life persists on our planet. Supernova explosions, though offering a spectacular view from a distance, pose hazards for onlookers nearby. Neighboring supernovae can impact Earth-like planets' biospheres through high-energy gamma rays, cosmic rays, and prolonged intense X-ray radiation, potentially harming terrestrial and marine life and affecting the ozone layer. These relatively infrequent yet potent events raise the galaxy's overall danger level, akin to the threat posed by more common explosions. Supernovas and Earth's vulnerable shield. Now let's talk cosmic fireworks, supernovas. These celestial explosions aren't just spectacular light shows. They've got some serious power. A single supernova can outshine our moon, and that's not even the most mind-blowing part. Recent research has uncovered some eye-opening findings. Turns out, certain supernovas don't just stop at putting on a dazzling display. They can potentially mess with a planet's ozone layer, exposing life to some seriously harmful radiation from our very own sun. Now, you might think, but they're so far away, how could they affect us? Well, buckle up. While the initial burst might blind us with visible light, the real danger lurks in the shadows, cosmic rays. These sneaky particles can wreak havoc on our ozone layer, leaving us vulnerable to the sun's unforgiving UV rays. Cue potential extinction event. But hold up, no need to panic just yet. Astronomers have been keeping an eye on the cosmic neighborhood, and thankfully, there aren't any supernovas poised to ruin our day anytime soon. Yet, there's this new kid on the cosmic block, a specific type of supernova that, when it happens near a bunch of cosmic material, could shoot out hazardous radiation in all directions. Picture this radiation bombarding a planet like ours, messing with its protective layer and setting the stage for a potential cosmic catastrophe. Think of it like a lethal combo punch. First, the X-rays hitting us like an interstellar laser show, then cosmic rays arriving fashionably late to finish what the X-rays started, leaving our biosphere in a bit of a fix. While the chances of a close supernova posing a direct threat are slim, there's evidence from when that suggests a supernova might have had a hand in a prehistoric extinction event. Fossils hint at a link between a supernova and some crispy plant spores from around 360 million years ago. So, while we're not in immediate danger of a cosmic apocalypse, it's fascinating to ponder the cosmic ballet happening light years away and its potential impact on our little blue planet. The James Webb Telescope recently found something that's absolutely mind-blowing. Sadly, it's not getting much attention yet. Scientists and space fans are buzzing about it. Guess what? They've just launched cool JWST special edition phone cases for the new year, and you can grab one right now. Click on your screen or check the first link in the description to see them for yourself. Do you believe that Betelgeuse's potential explosion will significantly impact Earth's night sky? Share your thoughts in the comments below.